If you're tuning in for the very first time ever, I want to say, hey, welcome. Welcome. And take a minute. Click subscribe, smash the bell. I'm always doing cool shit like this, like every flipping video. So take a minute, tune in, dial in, tune it up. Let's get going with this. And if you're following along with the saga, that makes you a repeat offender, and I want to say thank you and welcome back. So I have a dilemma here. I've got a very long story stretched out over multiple months that I need to explain to you guys. It's about an sb220. It's going to show up right here on the workbench here in just a minute. I'll snap my fingers and it'll be here. I've been working on this same amp now for, well, let's face it. This is a computer ago, literally. I had an old computer that I was running on that I was doing all my video editing on, and it got so slow, and it was time to finally upgrade and come off another program. And this is back in the very beginning of 2020. So last year sometime is when I started on this. There's a whole bunch of the video that I shot, like me unboxing it and getting it out and explaining to you what was going on. And what ended up happening is this amp has got a lot of deep-seated problems in it. A lot of the wires in it were broken. There was a lot of stuff that was going on. And my only mission here is to monoband this sb220. Believe me when I tell you, this is not one of the pretty little gems that we'd want to keep as a multi-band unit, but this is something that's going to be used as a driver, and it's okay for us to cut this one up. It's okay. We ended up getting the band switch out of it, and we turned it into a monoband box. Band switch will go on to live to help another person have a multi-band sb220. Well, when I changed computers, I took the old hard drive out of the old computer and proceeded to put it in the new computer, but as a backup drive, as data storage. And on that drive, I had saved, in a big file says, do not delete, the files for this video. Now, what happened is what you'll see. I'm going to bring you, the video is going to start kind of abruptly because it's missing like 4 parts. I can't find the video files. So I want to give you a quick little preamble on what's going to happen next. So the video is going to start abruptly, and then it's going to run on for about 30 minutes, and you're going to get to see me do repairs from a year and a half ago, or a year ago. And then we're going to come back here, and I'm going to explain to you where we're at currently, and then we're going to move forward to completion. Because I've had some huge mountains to climb when it comes to the primary replacement part. And at this point, we're at about an 80% replacement on components inside the amp. But there's a long story that goes along with this, a story that you all need to know. But where we're going to start out here in a minute, we've skipped over all the other stuff. We've skipped over, here we're taking it out of the box. We've skipped over, hey, this is what our motivational goals are. We've skipped over, this is our end goal, this is what we're shooting for. And we're literally at, okay, I've already done a huge chunk of the repairs. Let's go and start here. It's like 2/3 of the video is missing. But I still have all that other video footage that I want to show you guys. It'll kind of lead up to where we're currently at here today. So, on that note, let's let the video roll. And I'll be back. Ready? Set? So, we're just going to ignore the mess in the background because this is all the garbage that I've taken out of the amplifier to make it nice and pretty looking so far. We're going to go over here and we're going to talk here. This is our input network here. Okay, so our RF comes in through the brand new piece of RG400, goes through the relay, comes out, goes by a capacitor, goes through an inductor coil, goes by another capacitor, and goes out this other piece of RG400 over here to the input. So I go to set this up last night. This is like 8:30 at night last night. Now the tool that I use is the very famous KC901C. And I bought the C when it was the latest model, the latest and greatest model in the universe. In the whole universe. I love this thing because it's so flexible And it literally does everything on Earth. When God was born, the next day the KC901 popped into existence, and I praise Jesus for it. So listen, this thing caused me a great deal of stress. The first one of these that I owned, this one here, upon arrival into my world, it lasted 1 day, and then it had some kind of failure. In the same output section that allows me to do exactly this. Now, this particular function, which this is your frequency across the bottom, or width, okay? Frequency edge to edge, this is the lower, this is the upper end of the band. This dip represents resonance. Otherwise, resistance to RF going into or through something, okay? I'm completely blind without this piece of equipment. The best analyzer that is currently out there that is under $1,000 will not allow us to do what I'm going to show you on video here in just a minute. It'll allow me to do a static dip test like this. It'll go, you can hit send or start, and it goes, and it'll show you. But it won't allow us to do this. I am not touching the analyzer. I'm not telling it anything. It is making a real-time meter adjustment measurements every single half a second. It's going pew, pew, pew. Most of the analyzers on the market today, that if you want to pay under $1,000, will not allow us to achieve this data set. This was $1,950 when I bought it, this tool. And this tool is what's allowed me to do so much shit. My business partner and I were so excited when we found this thing. I was like, dude, we gotta buy this. We've gotta buy this damn thing. And so we went off and spent $2,000 some to have this piece of equipment sent over here, and then it failed within the first 2 days. I went to send that other one back to China as a warranty return, and DHL couldn't find where the company's based out of. If you understood how the address system works in China, it's a mess. It's a mess. It was like $300 just to send the meter back, and then DHL couldn't deliver it, so they sent it all the way back here. I don't know what I paid them for other than to hold on to the meter for a couple weeks. The guys at D-Space that make this KC901 analyzer, which has changed very little since 2016 when I bought this thing. They've gone up now. They've got them that go all the way to like 30 or 40 gigahertz. This is the 100 megahertz or 100 kilocycle through the 3 gigahertz range. But what we're showing you here is input tune. So what happened is last night as I'm working on this thing, I don't know if I had a bunch of static electricity built up on my iron. I don't know. But it went from everything working great to this thing showing me an infinite return, no matter what I did. And it led me to freaking out last night. Because without this, I can't get other things done. Like, I can't get hardly anything done. My whole one is none, two is one thing that I have going on in my world. This is the only one that I have one of, and it went down on me last night. So I got up early this morning at like 5 this morning. I just gave up last night. Just had enough. And if you can't hear the lack of enthusiasm in my voice for this particular amplifier in this project, there's a reason. I got up early, and finally at about 1 o'clock this afternoon, after a lot of testing and about 7 billion screws to take this thing apart, I was able to discover that these 4 things had gone bad. That is a 4.5 ohm resistor, okay? This is, in my opinion, a transistor, but the way it was metering was a non-polarized colored LED resistance load diode. That's what the equipment said when I pulled it out. This one was metering as a short. This here is a protection diode that breaks down at about 650 volts. And this here is a shock diode. Well, these big Mama Malou cans and my air solder unit. In a very careful amount of time with very, very fine tweezers, I was able to fish these parts off the board. And I was able to fish the parts out of the other analyzer. See, this analyzer's got 3 different ports on it. So this allows you to do RF in simulation from here, signal out, and source out. So this section of the analyzer, the other one, is what had failed, but I was able to find all of these exact components, and they were still good in the other unit. So I swapped them to this board because the RF output section is what's good on the other unit, and this is still good here, these 2 other sections. But I was able to find the good parts, so I slapped them back into this one unit. The main processor for the source out sig sense from here is what failed. The processor unit. So the whole RF tuning section that allows this to be resonant and networking, or allows it to show us what we need for data. That processor that controls that section, everything down from it is good. So I was able to fish those parts out, and by a miracle from God, I was able to get this thing to work. It passes its internal diagnostics program. There's a way that you can loop the RF in to the source out to the AF out, which I'm not going to get into in this particular video, that allows you to be able to check the accuracy of the data being displayed to you, and it passed with 0.001%. So I was able to continue forward. My $1,900 analyzer isn't garbage. Now this same exact unit today is now come down to a brand new one's $1,300, and I found them on eBay last night for $1,000. So I purchased another one of these last night. That, and my good friend Zane at Big Rig Radio, he's the only other person I know that has one of these, stepped up to the plate like, oh my God, I couldn't believe it. I called him last night because I just needed somebody to vent to. I tried to call my business partner, but he was completely unreachable. I don't know what the heck's going on with him. I still haven't heard from him today. I hope he's okay. I called him to vent like, oh my God, my shit broke, BBI. And he's like, dude, chill out. And just as smooth as like a freaking ninja, he just goes, brother, I got you. He's kind of like in Pulp Fiction when the wolf shows up. He goes, no, man, I got you, don't worry. And I hear him, hold on, let me get a box. He gets himself a box, packs up his KC901, and he overnighted it to me. I'll have it tomorrow. So I'll have it as a redundant piece of test equipment until my replacement unit gets here. And then on top of that, I contacted DeSpace, and I think they're going to send me a whole replacement board. So, but that was really freaking me out because I got 5 amplifiers lined out I want to do. So half of this day was lost. Well, 2/3 of this day was lost. But at the end of the day, what I'm standing here blabbering my giant face hole about is this dip. Let me show you why this is important. So when you take and you monoband the holy shit out of something like this, okay? When you go, just because it's sitting here on my workbench and it's working perfectly, we're going to take and make the amplifier work in like this much spectrum, like nothing, right? So I want to make it so it's flexible for where the guy wants to use it, and there's going to be variables in the station, like coax length and placement and connectors, and I can't make this just a super narrow band response. Now I could take a piece of ferrite and put it down here in this inductor coil and make the response of the entire network lay down really flat over a wide diverse frequency, or I go this route. Where this is at is 26.90599 megahertz. Okay? Basically below channel 1. And our top frequency is 27, this is channel 20. Now this gentleman did not lie to me, and I totally admire that. He says, man, I'm going to use it on 6. I was like, all right, man, I get it. I cannot stand people that are going to call me and say, "Oh man, I'm going to use it on 10 meters." I don't care. The only people that care are the FCC. Okay, there might be some ham guy out there rolling over in his grave right now, but the point is, I'd rather give him a hyper monobanded input, which means absolutely no deviation out of frequency on the output side. So be truthful with me. Trust me, it'll help you set up a way better amplifier in the long run. So by turning the band knob now on the front, we have a nice, smooth 1.0 or less input tune. All the way out to about channel 30. A little red hash mark is channel 20. And I can take it to 1.04. 1.040. Which is almost dead nuts. You can't ask for less than, or better, less, better, different than that. But allows us to have flexibility so that when it gets on his end, all he's got to do is put his watt meter between his driver and this box and tune it down for the lowest input signal and reflect. All right, now we got the input network straight, which took 2 days. I hate this kind of technology. Hate it. My big hands weren't designed to work on it. I like big parts through board technology. This meter is a lifesaver for me. This is the unit that allowed me to really be able to figure out LDMOS, to have the ability to have a completely smooth linear display of frequency and response. I can literally span this. I can now see from 0 to 100 megahertz in response all the way across the band. Is a blessing, in my opinion. And what we were just looking at, a sliver of knowledge of about that width in response. I was freaking out last night. Big props out to Zane at Big Rig Radio. Thanks, man. You stepped up and hit a home run. Big thanks. All right, let's go to the top side. I did some work on that yesterday too. So, all the circuitry to make this meter in the front works and is appropriate, and all the wires are hooked up in the right place. The problem is the actual meter movement itself is fucked. So, the way it's set up now is that it will move about 3 needles width. That's it. The plate amp, on the other hand, I don't know, I haven't had a chance to test that yet because we haven't gotten the amp fully ready to go. So what I did in here yesterday is I built a different tank coil for it that isn't made out of used mag wire. Mag wire's really nice stuff. I've got mag wire this thick. It's just I wanted something a little bit clean and I wanted something new. After all the jism that I had to wash out of this thing yesterday. These are my brand new set of RF parts, otherwise Penalabs, Taylor tubes, same thing. It's whatever RF parts once I've printed on the thing. It doesn't really. I've got my anode caps from RF Junk. I really strongly suggest everybody look at buying a set of these. It makes a huge difference. I've got another one that I've got to work on later on this week that it's got chimneys in it and I want to shoot a before and an after. So I'll take one of these anode caps off and I'll put one of the shitty little stock caps on it. Sure, I got one of them little bit shitty bastards. Shitty. I'll put a stock anode cap. Here, it's the best way to show this here. I'll put a stock anode cap on one of the tubes and I'll take the FLIR and I'll go from right to left. And this, because just of the massive amount of surface area, like 14 or 16 times the surface area of a stock anode cap, will help dissipate the heat better, which makes the tubes last longer. The last set of tubes that I had that were my test tubes, they lasted 7.5 years, and the only reason they ended up having failures with them is they got dropped. If you guys remember, the one tube cracked, and then the other one, the filament fell out the bottom of it, which is kind of cool. We take a minute and we look through the base of this thing. I'm not going to be able to get close enough with this lens. The filament was a coiled wire. It literally unscrewed itself. So if I turn the tube upside down and I just shook the filament all the way back up the shaft, and now it's back in its stock place. But 7.5 years. I called them my sloppy hose, but we got new ones. So I went ahead and created this guy new parasitics, even though it's not really necessary since we're monobanding. If you get everything in your network appropriate, you don't really need to go with parasitics to suppress if you're going to be in a mono frequency situation. But they sure are helpful when you're trying to tune across a large frequency spectrum. So we're going to go ahead and we're going to put them back in there anyhow. This is our old set of parasitics. They're going to go in the garbage. Now the sb220 uses 2 plate chokes to achieve the out of resonance effect that you need to have for your plate choke circuit. The whole point behind a plate choke is to make it so that your high voltage circuit is not resonant, so the RF doesn't want to go this way, it wants to go this way through the blocker and out through your antenna. If you're trying to make an amplifier that's going to be responsive a lot across a large frequency, you have to use a large amount of induction. A lot of inductance spread out over a large frequency. So it shows a really high aspect ratio of like 700 to 1. But the high voltage DC can fly right through it, the AC RF cannot. That's how this works. I could have probably gotten away with just putting a solid bar here, to be honest with you. There's more than enough inductance and a high enough amount of turns here to keep that principle from coming into effect and it backing up. This is what was in there. This was hand wound. I didn't feel comfortable with it, so I replaced it with a stock one because I bought stock in buying these because I work on so many sb220s. The other thing is that I replaced the I can't remember what the value of this was. It was really stupid high, like dangerously high. It was lifting the ground potential on the glitch resistor. It was taking it way high, which would have made all the meters read wrong, which would have made the bias have to have all this added garbage to it. Yeah, it was 1 meg above was the glitch resistor here, so now we're sitting at 1.5 ohms. We're sitting right at 1 watt. I got there by using 2 half-watt resistors, which is really all you want. Anything more than that, it's going to completely screw up your metering ability, and it's also going to make the tube act really weird. Hence the reason that they had this many diodes. This many diodes were hooked up for our bias control. They had this stuff down here, and then they had this underneath on the relay. Just went ahead and put the stock Zener in there because this is a stock high voltage power supply board, and we put the stock Zener in there. Those aren't cheap, they're about 30-40 bucks. When you can find them, they're pretty hard to find from time to time. And of course we did the capacitor bank replacement. All of this is working really good. I tested our doorknobs, they're in top shape. I did emulated load, where I tied the 2 tubes together, and then I brought a resistor over to the cabinet, which if I remember correctly was like 1.7, and divide that by half, it was like 800 whatever ohms to ground. I don't remember, I did it last night before the frickin' thing failed, and that was about a million thoughts ago, so I'd have to pull the data sheet, and then whatever number of tubes you have, you add that together, and then you take that total resistance and you divide it by half, or divide it by the number of tubes. Pretty close. So I can't wait to see what we have going on here. We might need to take a turn out of this, like 1 full turn, and we can simply do that with solder, but we'll see. We're pretty darn close. Very happy. Very pretty, clean, new, nice and neat. So let me get the parasitics running, and I'm very interested to see if the plate meter will pop up and show us 0 signal once we put some high voltage on the anodes. I'll be back. I feel like Gollum from Lord of the Rings. This is where my analyzer lives. My precious, my precious. Oh yeah, it lives in an airtight Pelican case. That's how important this thing is to me. I'm not kidding you. Yesterday, I was losing my freaking mind. Okay, I'm going to shoot this little segment for my friend Bob at the car wash, who's really struggling with this. He doesn't understand what I keep telling him to do. I'm like, well, how you check for bias and cutoff is do it this way. He's like, I don't understand. Okay, so the filament runs on, you can put AC and DC voltage on the same leads. Totally can, okay? So the filament runs on AC. Okay, so we're going to set our voltmeter up for AC, and we're going to attach our black and our red leads up to our filament leads on our sb220. He's working on sb220 right now also. So go ahead and we'll turn this on. So our filament comes on board, which is roughly about 5 volts. So we see we've got our voltage for our filament. Now, when we step on the pedal, we're not seeing any voltage flop. So Bob, what I'm trying to explain to you, bud, is for you to be able to check to be able to meter the other side of the cathode. The only way that you're going to have access to the cathode in the tube is going to be through the center tap of the filament. Otherwise, really complicated. We're going to leave the red wire attached. We're going to disconnect our black wire, and we're going to hook it up to the case. We're going to go look at our DC voltage. Please note, when we went to the case, we're showing exactly half of our AC voltage. There's a difference. So now we're going to go and we're going to flip our meter over to DC. Now what that's allowing us to do is look at the voltage potential between the cabinet and the center tap voltage. Okay? Right now there's 120 volts present in DC, positive DC voltage. It is present from the center tap, measuring from the center tap of the transformer, the filament transformer. Okay? Otherwise being applied to the cathode of the tubes, which are cutting the tubes off and are not allowing it to rectify. So when we step on the pedal, we're now dropping down to below 5 volts. You go much lower than 4.5, maybe 5 volts, and the tubes will have a tendency to run away. As soon as you step on 0 signal, they'll start making their own little happy dance and they'll run away. Okay? It's called bias. We're controlling the throttle pedal, the gas pedal, that's allowing the tube to do stuff with the RF versus being in cutoff. Right now it's in full cutoff. 120 volts roughly is more than adequate to fully cut the tube completely off and to stop the tube from being able to rectify any RF. So when we step on the pedal, that's what all of our bias that we just pulled out of here yesterday, all of this shit, and this shit got rid of by simply changing that out and going to the stud diode that's in there, the Zener that's supposed to be in its place. We now have a fixed reference. Okay? Now we can make this pull when we switch to our center tap by adding diodes to this. We're going to add it's going to add more resistance to the circuit, and in theory this voltage will drop and drop and drop and drop and drop and drop and drop. We go too low and we're going to start to fall out of the class AB1, which is what we want to be operating in, and according to the data sheet, right at 4.5 volts is perfect for where we want to be. Okay? So what you're looking for is this on the DC side, with your wires hooked up specifically this way. That's why I asked you, do you have bias flop? And you're like, no. And I said, well, this is how we meter for it. And Bob, the numbers that you've come back with me are completely wrong. There's no way that you can get those kind of volts. He was like, it's got 495 volts on it. I'm like, what are you talking about? So So we'll go back over to the AC side. This is not the appropriate way to meter it. None whatsoever. You see that? See how the meter's jumping all over the place? That's not what we're looking for. I need you to tell me what the DC is. See this? AC for checking our filament voltage, which is roughly 5 volts. When we flip this back over to DC, we attach the ground to the case, and it doesn't matter which lead the red lead's on. That's how we check our bias. So I know our bias is right. I know that our zero signal is going to be correct on the front of the amplifier. Now, bias is also measured in the amount of current draw to make the tube do something. Okay, so we're going to have to come back and look at that with our plate meter here in the front for us to be able to set our absolute. But there's only about 7 trillion sb220s out there, and that we put the right zener in there and we're showing our right voltage reference. I can almost guarantee you, unless there's something wrong with my brand new tubes, which I know there's not since I've already used them in another amplifier, that we're going to show the appropriate amount of milliamp draw at zero signal. But that's how we check for our bias flop. And to me, Bob, what's going on with your box is that is not dropping low enough to let your tubes take off and run. Okay, now let's go work on the top side. Well, as you can see, that sb220 is no longer on this workbench. And that's because I'd had enough of it. Couple things. So I was running it, and I ran it with the striker hitting it. I was getting about 1100, 1200 watts out of it with 90 watts of drive, which is perfect. And so I reached on it and I turned it up on its side, and I went to dick with the input tune again, and I wanted to turn it off. I reached up and I went click, and the glitch resistor went poof. I'm like, okay, now I had those little tiny 1/4 watt resistors in there for a reason, and I replaced them with a 2 watt, and it smoked those. And then as that resistor smoked, it sat there and went and it smoked back to this zener right here. Blew this resistor or the zener completely up. And I went, well, that's interesting. So I went and I checked the whole board. All the protection diodes, or not all the rectifying diodes, good. Everything on the board's fine, just the glitch resistor was blown. So I replaced that with the actual 2 watt, and I fire it back up. Boop, pops that 2 watt glitcher again. I went, oh, that's bad. So I figured it was in the capacitor bank. So I disconnected the, shut it off, made sure we bled down to 0, and I disconnected the high volt leads coming off the power supply, off the plate transformer, and that's when I could smell it. And I went, oh, I hope not. I went ahead and I pulled the capacitor bank out and I checked the capacitor bank. Now I'm on this 2 full days now. Every single time I turn around, something else is popping. So I pulled the capacitor bank out. Capacitor bank tests out fine. I load tested each cap, test out fine. So now I have the leads, because I had to take the face off. I have the lead, and I had to take the high voltage board off. So I got the leads hanging off the side that come off the plate transformer. And I just turned it on, and the plate transformer just sat there and went. Well, anybody that smelled burned up transformer knows how lovely that smells. That's what this room smells like right now. That amp is inside of a plastic bag, inside of a plastic bag, inside of a plastic bag, outside. Sitting in a tote with a lid on it. Stinky. End of the day. So this is where it sits. I called my guy and he told me that he wants to get a replacement plate transformer from EPD, which should take a couple weeks. We'll be back to that then. See ya. So let's talk about the toils and the trouble of the plate transformer. So what happens is I called up EPD and I ordered a filament transformer for a 3000 because I was getting ready to do a wizard. This is all the garbage I took out of this thing. This is our bias string. This is part of the bias string. Really funky shit going on there. Here's our knobs. Here's our feet. Here's that same sb220. So I call up my buddy Peter over at EPD and I said, hey man, I need one of those 2-spec sb220 transformers that I had you design. Drop-in replacements. And he goes, sweet, okay. And so they sent me one. And it came out with a filament transformer on a wizard. You guys watched the wizard about 2 months ago get done. In the same breath, my buddy Paul Browning, pardon me, 222 out of Illinois called me up and said, hey man, I need a replacement sb220 transformer. So I kicked him on to Peter and them guys. And he went off and he bought one. And he put it in his sb220 and ran it for about 2 days. And then the whole transformer melted down. The original sb220 replacement transformer that we built for the Heath kits was too high in plate voltage. And so you'd turn it on and the voltmeter over here would run to the corner. Bing! And I'm like, okay, but when you key up and put it underneath and load it, drop back down to about 3,000 volts. So it's within the safe range in operation. Anything ain't about it. It lasted 2 days, and then all of a sudden the filter bank went pow and blew out the side. I went, whoa! A little too hot, overloaded the capacitors and blew them up. Okay, we get that. I understand what that means. Dumbass. I'm a dumbass. So I call up Peter, so we got to change the design. So we back it down by like, on the output side by like 100 volts. And he sent me another test piece. I put it in that amplifier. Worked great. Worked great. I said, no problem. Well, I only run it for a little bit on the workbench. Didn't blow the capacitor bank up. And I said, no problem. I approved this. We sent it out. And that's the thing that he's been building. Well, it came to our attention that unless you've got a brand new capacitor bank inside your amp, the old school paper capacitors that they had in this thing, it's still a little bit too hot. So Paul, nice guy that he is willing to work with Peter. We go and we do a revamp on it. I go and I dig through and I get an sb220 plate transformer. I got an extra one sitting over here, an actual legit drop-in plate transformer. I hook it up, I run it, I meter the voltages, I tell him what it is, and he builds a 2-spec sb220 plate transformer. The volts. Not overclocking nothing, not nothing. Just straight to the point. Paul hooks it up on his end and has problems with it. Meanwhile, I've got one sitting over here on a board that I ordered like 3 months before Paul's blew up. And I now recognize this out of the same batch. Going, oh no. So I had to call up Peter and said, hey man, I got one of the other ones that doesn't work. What do you want me to do with it? He said, send it back. So I sent it back. He built me another replacement one. So I went and I took old Smokey out of here and we replaced it with this plate transformer. This is our latest and greatest test piece. That whole process took several months to get done. I hate to say it. Several months to get this, all the bugs worked out of that. On probation, I'm over here trying to get this nightmare figured out with EPD. Now, you did hear me when I said I have an extra sb220 plate transformer. I have the legit transformer. We're going to wire this one and we're going to test it in this unit. If I don't like the voltages I'm seeing come out of this transformer, like if it's not something that I can easily capitalize by changing out my bleeder bank over here on this capacitor board. That's another thing, is I just got off the phone with dude and I said, bro, honestly, these caps were made in the 50s and here it's 2020. So you're talking 60, 70-year-old parts that are up in here. I would feel better if we could put like another $150 into the budget and replace all your electrolytics, and let's give this the best chance of success that we can. The reason we want to go with this plate transformer is because it does produce just a scooch bit more voltage, which translates to more output power. That, and this is a true like 1.5 amp rated transformer versus the replacement transformer, which is 1 amp. So there's a little bit more push, a little bit more cushion for the pushing with this little transformer. That, and this is designed this century. Just saying. So we're going to try. But that brings us up to speed to where we're currently at. I took the old transformer out, and even after like 5 months in a bag, it still stunk to holy high heaven. I don't have it in here anymore. I took it out and literally ran it outside and threw it in the trash can. Okay, I didn't want to smell it anymore. Drop this one in its place. Now all I got to do is hook up my wires down here on the bottom side on the on-off switch, and the one that goes over here to the back distribution. This is our high volt lead that wraps around to the board. This is our other high volt lead that comes over here to the capacitor bank. I really want to see this thing go. Now, in the same breath, me and dude have become really good friends through Pal Talk, and he's a hell of a funny guy. And I honestly think that we just had some very small miscommunication, and whatever. I really want to give this guy the best opportunity for success that me personally I can give him. So it's already got upgraded 6 amp diodes in here. I am really toying with the idea of pulling this whole board out, replacing all the high volt wire in it, which is this lead here, replacing our ground lead. Because honestly, from the get out start point on this thing, the whole point behind it was to make it within a very, very small budget. I got to do all my work here. All the work in total on this box has to come up to less than 800 bucks. So it's not like we've got a huge amount of money to work with here. Like we can sink another $300 or $400 into it and put a brand new rectifier board in it and the soft key and all that other crap. He doesn't care about any of that. It's a monoband, right? I mean, look. Now to add insult to injury, this is my air tuner that was in here. This is after I've kind of bent it out straight. From me very quickly wrapping it up and throwing everything in here, and I had this tied into the front of the amp. This thing was floating around, and for some reason it got crushed. Now if we look really close, I'm pretty good, but I'm not the greatest in the world at making these little micro fins. Let's go to manual focus here. Making these little fins not touch, and they're touching in several spots. So unfortunately this little tuner, and let's face it, these little tuners are getting harder and harder to find within the capacitance value range that we need. That thing is like, here. You hear that dragging? That's no good. So I need to go and find myself another little air tuner, which in a box around here I know I've got more. I'll find something else that we can slide in here and make work. I pray. At least his blockers are hard. I don't need to come out of those. But that's where we currently stand. That's where we're at. So what I'm going to work on now is we're going to wire in the plate transformer. I dare not risk run this with this capacitor bank that's in here. So I got to get on the phone with Harbaugh and get them to send me a replacement cap bank, which I think all in all is going to be the better. And I don't mind if, look, I like this guy. he's turned out to be one hell of a cool dude. And if I got to come up a little bit out of pocket to help this situation get done, I think it's going to be best for everybody involved. So maybe I got to buy a cat bank or something, you know, and it is what it is. You just want to see people be happy, right? So that's where we stand. And I appreciate you guys watching the last little hunks of video. I know that it really doesn't linearly make sense. You missed out on the part of me talking about this beautiful gem. This was our tank coil that was in here. That's a nice piece of mag wire, but it's not nearly long enough. And yeah, the eyelets on here were held on. They were just crimped on. They weren't even soldered. You guys missed me replacing and rebuilding the suppressor, parasitic suppressors. You guys missed the whole conversation that we had about this diode string. This was the bias string that was in this amp. It had the stock Zener in it, which is this Zener here, which is completely blown. There was this cobbed Majab stuffed up in here as well, behind this board. We had a bad light element. We had a completely melted and burnt through short and about 4 spot pieces of coax on the input side. This is how the grids were grounded. This was one of the high voltage chokes, one of the high voltage plate chokes. This is what they'd stuck in there as a replacement. This is how the other grid ring was grounded. So a lot of bad mojo science going on, and a little bit of just overall bad ick. You know, the closet technician mentality going on here. So makes sense, though. That makes sense. I did have this running, and it was making good power, but when that plate transformer, which has obviously been very heavily abused, you guys missed out on me having to scrub all the burn mark out of the inside of here. When I first started on this thing has been shorted out multiple times. That original stock plate transformer, the capacitor bank that was in here, was hot, as in like it was no good. This is a replacement one that I had sitting here because I was trying to save the guy a little bit of money. We put it in here as a just kind of, I want to help get you done. The cap bank was already pre-blown when it arrived here. We had all this funkily whack shit going on up here in the front. It doesn't surprise me a lot that that plate transformer, which they are normally very, very forgiving, but this one had been very abused that was in here, let go. It didn't surprise me that much. So you guys missed out on all of that, and I'm just bringing you up to speed on it verbally. So now we're going to proceed forward towards getting this thing done. And our first step is wiring this Cogma job in the hole. So let's do that. I'm going to bring you guys in kind of end of the stroke here. So I learned a long time ago in a galaxy far, far away that installation of this capacitor bank goes much, much easier if you just take and sand a few millimeters off the bottom of each one of these spacers. So I just put it on the mother and father of sanders over there, and of course it cuts it so much that I got to come back through and scrape it with a knife and file it down. But the main reason we do this is to help keep the capacitors from getting crushed when we go to tighten this thing down. We sandwich it together and make a pancake. We dial this down a little bit. So we've got our new capacitor bank built. Now these are Cornell Dubler 450 volt, which in theory should be able to comfortably hold 3,500 volts worth of shmoo. Well, Once again, we spec'd out this plate transformer to be able to make 3,500 volts of shmoo. The problem is a lot of guys, what they do is they'll buy the plate transformer from EPD, but they won't replace the capacitor bank. This thing. Now when this showed up here, you got to remember that this is a rebuild on a budget, okay? When this showed up here, the capacitor bank that was in it was junk. It was garbage. It was hacked together garbage. And so on a budget, this is a used capacitor bank. I said, hey man, I got a used one over here. I'll sell it to you at a cheap price. We'll slap it in there and it should be able to get you by for a little bit. Well, when the plate transformer went zzz, pow, blew up, I was like, man, the old plate transformer had been so abused at that point that it was done. It had nothing more to live to give the word. So I was so grateful when I got this transformer. This is the second go around of this transformer, by the way. I think I've already talked about it in a couple previous segments, because this is the redesign of a redesign. That I called him and I said, hey, did you got like another $100 and something you could put in this in the budget? And he says, well, I guess if I have to. I was like, okay, sweet. So I got this ordered and put together. Now we're going to drop this in here, but I wanted to modify these plates and I wanted to bring you up to speed where we're at. So I got the transformer all wired in. It's all tied in on the bottom on the on-off, the low high on-off switch and stuff. So the only thing we got left to do is to attach these leads to the capacitor bank, and we're going to bring it on real slow. So I'm going to convert this over to 110, put it on a variac, and we'll dial it up real slow. And then I'm going to sit here and I'm going to watch it. Because I've got another stock sb220 transformer over here, but it's used, so I can't guarantee that. Where this is new, I can guarantee this. If there's a problem with this, I can send it to EPD, but we're going to run this up slow. We're going to give it the best chances of survival with brand new caps that were built not even 8 months ago versus capacitors that were made 45 plus years ago. We'll see. We'll see what happens. Have faith. We'll see what happens. So I couldn't help myself. Listen, once again, this was a repair on a budget, okay, which I'm not making any money on this. I'm literally in this like the cost of components plus like 3% maybe at the most. What can I say? I like the guy, so I don't understand why. Anyhow, I went ahead because I can't stand this stuff. This is the old high voltage wire. Went ahead and replaced this with new silicone. Went ahead and drilled the board out and made it so it was right. Heat shrink both ends. Put a new piece that comes down here. It'll attach over here on the capacitor bank. Replaced the ground wire, which is solid core. Pulled that out. Replaced this with Teflon stranded. I got to replace the red wire that goes to this corner off the metering circuit because it broke off. We cleaned everything else up. Remember, we had this thing running. It was running when the plate transformer decided to up and fart out its face. And it's been so long that I want to make sure that I got no open diodes. Good. 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 I want to make sure I got no open diodes, because if I go and I run this, I don't want to have to come and take the faceplate off of this again because there's a short. But I remember I checked these, but nothing's a hard short, and they're ringing out to 52.527, so that tells me that the diodes are all good. So let's see, my ground's reattached, ground reference is reattached. Is it the coating on the resistor that's coming off, or is it the resistor that's bad? Really? Really, voltmeter? Really? You know, I think I've about worn out these leads. And what are they, like $5 on Amazon or something? Okay. Okay, so that went out as well. Let's put a new glitch in it while we're here. We have really easy access to it. Let's go in here and let's simply grab this here. Grab this here. Pull that out. This is what caught my attention. A little chooched into the chotch. So let me grab another one of them. New glitch, 1.6 ohm tested. So let's rotate this around. Now the hardest part of this whole thing oh no, tuner. You rotten. Tuner's sitting in there spinning. Sorry, I started daydreaming and thinking about all the other shit I gotta get done here. God dang it. Nope, nope. Turn it. Turn it. Come on. There we go. There we go. Okay, there we go. Okay. Okay, so we got it all running. High voltage circuit's working well. Let's see if we got any leakage through our brand new capacitor bank. No, negative. We got nothing really. So this is our line voltage going in from our variac. We currently have this wired 220. Now please note this needle's sitting at 0. The signal is coming from the board, but there's something wrong with this meter movement. I think I've got another one sitting over there, I hope. So hopefully we'll be able to get this changed out and fixed for $819. This wasn't in the original price either. It's okay. I don't care at this point. I just want to get it done and get it done right. So let's talk about the big elephant in the room, is the plate transformer. This thing right here. Right now, there's currently 120 volts going in, which would give us 244 volts in a 220 setup. So if I had this wired 220, this would be the same plate voltage, is what I'm getting at, and it's 240. So the capacitor bank is more than capable of handling 3,500 volts. We have to keep our plate voltage underneath 3,500 volts for our capacitor bank not to explode. Now, this old bank that was a used one, because remember the first one that came in here was blown to shit up. You get more past about 3,100 and I'd be a little bit scared of it. So I'm glad we went with the replacement bank. This makes me feel more comfortable. Because remember, this is rated for 110 volts. Well, let's see what happens when we actually drop our voltage down to 110 going in. Okay, here's 110.5. That's 2,700 volts. This switch is flipped in the high position. Let's go to the low position. 2,300 volts. Okay. Let's go back over here to the high position. I just got done asking my buddy 819 what's he got coming out the wall. He goes, well, it's 220. I said, well, have you stuck a voltmeter in it? He goes, well, that's what I had the electrician come wired up for, was 220 outlets. I said, okay, so you don't really know. Let's go ahead, we'll crank this up. We'll go to the high side of things. So we'll go to 130 volts on the input, which gets us 3,280 volts on the plate with 130 volts going in. That would be on if we had a 220 volt, had this wired 220 like what it's going to go into. That means that there's going to be 260 volts on the input. So from 220 to 260 volts, which is a huge range, and most house current is 240, we are more than safe. It's a little hot, but it's more than safe. And this is float voltage. So what's holding this float voltage from creeping up any further is our brand new bleeders over here. They're keeping that voltage held back a little bit. We'll go ahead and we'll shut this off for a second. We'll show our bleeders are working well. We're going to work on this meter. But I still have zero faith. Let's go ahead and we'll bring this back on. We're going to run this at 120 volts, which would be a normal 240 volts if it was wired 220. And we're going to let this sit for a little while, because I don't want to call this a victory. See this margin of error here? Not error. The margin in the capacitor, we're giving ourselves 500 volts worth of capacitance margin in the bank, the capacitor bank. There's a 500 volt window. There's 3,500 volts worth of capacitor here. So we can run up to 3,500 volts, but that's its maximum. So we've just demonstrated, unless on the other end, at the customer's location, on the other end, if he's putting more than 260 volts in, which is going to be very rare, this thing is 100% safe. So this is really important to me to document this, because we've had one very, kind of problematic situation, and I just want to make sure that this design is right. The capacitors themselves is what I'm looking at. I'm not looking at the bleeders. Now let me turn the camera off, or the light off, to show you guys what I'm looking at. Let's bring this around. I'm having to sneak in. I'll take a picture of this. I'm sneaking in past the bleeders. Where'd we go? Come here. Let's turn our exposure down a little bit. The capacitors on the back side behind the bleeders are at 80 something degrees. The bleeders themselves are at about 200, which is more than safe. It's really important that I establish this baseline, and the fact that I keep this running for a little while and we just sit back and we watch it. Just sit back and we watch this. So, on that note, it's like the little engine that could. I'm going to go in the house, I'm going to eat dinner. I'm confident enough that I don't have a problem here. But time will tell. Time will definitely tell. Okay, I think I got all the bugs worked out of this thing finally. Had a biasing issue, we had all kinds of problems with it. So let me zoom in on the transformer first. Let's talk about this for a second. So this is the LT31, here let's zoom in a little bit more. I know you got it in your camera. LT31498 transformer from Electronic Product Designs. Okay, this is their phone number. This is the component. This is thoroughly tested. This has been run and then been sitting here idling. We have no over voltage issues. We have nothing with this. This is running almost hand for hand, just like the stock transformer, okay? Let me help verify this. Now, you're gonna notice something shockingly different here about what we had going on before. The meter was not working at all before, because the meter movement, this is the old one. This is junk. This one here is no good. That's a $200 meter. They're unobtainium, so I had to go into the stockpile of stuff and get the meter, because you gotta have a high voltage meter, otherwise how do you know when it's safe to do anything with it? You've got to have a measurement reference. You have to. You have to. So I guess I'm going to end up eating this meter. That's fine. I don't care. I'd rather this be safe than down the road, you know, it's just better this way. So anyhow, low on this unit, let the fan spin up, is right at about 2200 volts, and high is dead on the money at 3000. And that's at 240 volts going in, standard wall current. Okay, that being said, let's go over here and let's take a quick look at our meters. That's a 1000 watt slug in peak, 1000 in average, and a 5 watt slug in reverse back from the Bird, 10,000 watt dummy load. Over here we have a 50 watt slug in reverse, sitting between our bench 2-pill and a 3-foot hunk of coax. That doesn't matter because you have the ability to tune your own input with the dial a knob here, okay? So you have to tune your state, you have to tune this amplifier with 2 watt meters. One on the output, one on the input. I don't care what you do. 1 1 1 1 1 1 1 1 1 1 1. This is the radio. Hello, 1 2 1 2 1 2 1 2. Nothing, no reflect whatsoever. We are on the 1000 watt scale. Hello, about 20 watts going in. Hello, 1 2 1 2. Okay. Let's turn on the driver. Hello, goodbye. Obviously, we knew that was going to happen. Let's come over here and let's look at the input. Hello, 1 1 1 1 1 1 1 1 1. It's about a watt worth of reflect. Let me show you how little movement I'm doing to get that to be adjusted. Ready? Here we go. 1 1, hello. Maximum, just minimal amount of input. Now we're driving the holy bejesus out of this box. And all the meters are crying at us, stop! No. It's now monoband. It is what it is. Let's grab up our 2x time scale here. You should be able to tune this thing out to just 0, 0, 0 input reflect. 0. Hello, 1 2. It's radio. That's the amplifier drive going in. So about hello. Little hair about 390 going in. Hello, off the chart once again. So let's reach back here. We're going to go down to 5x now. So it's just like having a 5,000 watt slug. We're going to read that middle scale. We're going to add a couple zeros. Hello, 3,600 watts, 3,700 watts, no problem. Hello, hello. Two, 1 2. Let's come down here and let's look at our plate meter. Hello, hello. We're completely safe. No matter how we go about trying twisting this, this is safe. This is safe. So with the good capacitors, the rebuilt board, a good set of tubes, a rebuilt, remember, let us not forget this is the kind of technology we started with here. Okay. And this was our biasing circuit, by the way. And this is how we grounded our grids. All that's been overhauled. And just a very basic plain Jane monoband is all we done. Upgraded quite a few things, and it runs smoothly, reliably and well. I'm so glad that this thing is done. I just don't, from being the stinky thing that sat underneath my shelf for a couple months to just screaming out power and going to be able to run forever and ever and ever, I'm super stoked. Hello, audio 1 2 1 2 1 2 1 2. Hello, 1 2 1 2. Turn the drive up a little bit more here. Hello, audio 1 2 1 2. Hello, wow. Hello. One two. Hello, 1 2. Hello, 1 2 1 2 1 2 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2. Hello, 1 2. Hello, 1 2 1 2 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2. Okay, enough. Listen, my man, I'm going to give you some key tips. It's your amp. You do whatever you want with it. And I mean whatever you want with it, bro. You're not going to get me to say good, bad, indifferent, anything else. Okay? Now, the way the grid circuit's built on an sb220 is if you put more than 220 to about 230 watts of drive into this thing, it will disintegrate into a ball of flames. I have that bypassed for a reason. Just trust me that that's actually a good thing. At least the way I know you're going to run it. You're going to be able to smash the shit out of this. Okay? How you're going to be able to tell if your tubes are starting to go bad is you're going to start to see decrease in power for the most part. But I'm going to send you a couple extra of these. These are glitch resistors. Please note, this conductive screwdriver I've got hanging out here in space is a good foot away from the amplifier. I'm just going to use it to point at the glitch resistor in its location. If you drive this amp too hard, this glitch resistor is going to pop. It's going to go pow! And you're going to watch your plate bolt slowly drop off to 0. And it's going to shudder on the way, and you'll turn the amp on and off. And oh no, what happened? Don't panic. You're going to get out your soldering iron, you're going to unsolder this resistor, and you're going to replace it right here. This blue one. It's color-coded blue. Okay, big blue resistor. This is a typical, completely mono-banded box. I don't care what you put into this for the drive, you should be able to get it to go to absolute almost 0 over here on the reflect meter. Just by very small amount of tune input here. Now, because these tuners have been modified up in here, once again, there's like a huge amount of distance. Okay, this tuner here has been modified. Very small inputs on these two tuner knobs. Very small. Will have wild results of your output. So just keep that in mind. You've got all the upgrades in here that anybody would ever want for a monoband box, except for a soft start and a soft key. But that's okay. I know you're the kind of man that likes to hit the gas pedal when he goes to talk, click with the foot pedal, and you're not going to be using your ICOM whatever to key it with it. So that's it. This is an incredibly conservative, safe setup. Now, what I mean by conservative and safe is if we wanted to, you could put a couple hundred more volts on the plate and the amp would put out about 200, 300 more watts. Is it really worth it when 500Zs are $500 a piece almost, at least for the iMacs? The Chinesium tubes, like what's in here now. Anyhow, the moral of the story is this. It's done. It came in here. It had a whole bunch of problems with it. We've overcome all of those issues. It's all water underneath the bridge. It's got a brand new transformer in it that works perfectly. It's a conservative setup. I can't see you having any problems with this, short of maybe overdriving it and popping the glitch resistor. So have fun with it. Enjoy it. Now, if memory serves me, let me walk over here and look. I think I've got a top piece. Here's your top piece, I do believe. And I got your side piece sitting around here someplace. But we'll get that all installed. And what I mean by the side piece, oh yeah, it's down here. This is the lid that came with your amp. And whoosh, we're going to get this all put back together. We're going to slide it inside the armor. And we're going to have it professionally crated to send to you, which means a wood crate. These upgraded anodes are going to help you a lot, and that upgraded fan will help you a lot too. But we're done. We're absolutely done. I am done with this project, and I will be calling you later, my friend. And I appreciate you sending this up and letting me go through this and all the stuff that's gone along with it. Worth the tail end of the story. So, gentlemen, I want to thank every single one of you for tuning in and following along. I know this is a long video. sb220s are usually very time consuming. Big shout out to Siglent, XS Power, Bird, Coaxial Dynamics, and last but not least, but absolutely the most important, a big thanks to all of you. And no, I take that back. When this came here, it didn't even have a lid on it. So I'm going to donate one to the program so that the case is securely put together and transport, and it's safe for you on your end of the street as well. 918, I appreciate you. Be good. We'll catch you later. We'll see ya. Bye.